Hello everyone, welcome back. This is Mr. Osama Wasabi, and in this video we'll be discussing integrated rate laws. Okay, so let's get to it. Now, one thing you should understand is this. When it comes to integrated rate laws, what we're looking at is simply just the rate. We're looking at the change in concentration over the period of time. Now, they're called integrated rate laws simply because they are integrals, they are integrated. And you do understand that an integral is something that deals with calculus. So let's get to it. But before we do, don't forget to like and subscribe to the channel. Alright, let's begin. So to understand integrated rate laws, what you should first bear in mind are these two things. We have what we call a rate expression. And what we call a rate law. Now, in a nutshell, if you talk about a rate expression, you're talking about a way of measuring the rate of the reaction. But when you talk about a rate law, you're trying to look at a way of predicting the rate of the reaction. But one thing you should know is this. Rate expression is equal to the rate. And the rate law is also equal to the rate. Which implies that the rate expression and the rate law are equal to the rate. With this said, let us look at these two independently. Let's start with the rate expression. So since we're looking at integrated rate laws, I'll give you 3 rate expressions with respect to their orders. So for a zero order reaction, what you have to understand is this, that the rate expression for a zero order reaction is simply just rate being equal to negative change in concentration of reactant over change in what? Time. The rate expression for a first order is just the same. Rate is equal to negative change in concentration of the reactant over change in what? Time. And finally, for the second order, the rate expression will also be the negative change in the concentration of the reactant over change in what? Time. Now be mindful of what I've said, that the rate expression is simply just a way of measuring the rate of a reaction. So don't forget that. It's just a way of measuring the rate of a reaction. But now, when we get to what are known as rate laws, these help us predict the rate of a reaction. So I'm going to give you 3 rate laws with respect to our orders. I'll start with a zero order. The rate law for a zero order is simply rate being equal to what? K. The rate order for a first order is simply rate being equal to K, change in concentration of what? The reactant. Then for a second order, rate is equal to K, then concentration of what? The reactant squared. Now, why is this important? Remember, we're looking at integrated rate laws. Integrated rate laws come about as a result of the rate law and the rate expression. Remember, the rate expression and the rate law both give you the rate. This means that the rate expression is equal to the rate law. So, if you want to deduce something from this, take for instance, for a zero order. If you take the rate expression for a zero order, of which we know that the expression is simply negative change in concentration over what? Change in time, and equate it to the rate law, which is what? K. If you manipulate this, what will happen is that we can separate out what we have and put it in a manner that we can understand, say, in a calculus way. So we know that this triangle represents a delta. So this is the same as 1 writing K being equal to negative delta concentration A over delta at time. So we can cross multiply here. And if we do, we'll end up having delta A being equal to negative K dt. At this point, what we can do next is integrate what we have. So you can integrate this and also integrate that. For the left hand side, we'll take it from the change in concentration of A at the initial to the concentration of A at time t. But here we'll take the time from 0 to t. Now if we integrate this, the A will just get concentration A. Then to run from A0 to AT. And this will be equivalent to minus KT, which will run from 0 to t. So if you integrate the left hand side, you will just get concentration A at t minus concentration A at the initial being equal to negative what? KT. If you make concentration T the subject, then you have this. Minus KT. What you have here is the integrated rate law for what? A zero order. So this is the integrated what? Rate law for a zero order. Don't forget. Now we can do the same thing for the remaining orders in order to know what their integrated rate law is going to be. So if we want, we can look at the first order. Remember, rate is equal to what? Rate expression. So let's do one for what? The first order. So for the first order, we know that the rate is going to be K concentration A being equal to minus change in concentration of A over change in time. Then we can change up the triangles and put these. This will be minus D concentration A over D time being equal to K concentration of A. Upon doing this, we can easily manipulate this part here. If we manipulate it, we end up having a situation where we'll have 1 over concentration A times D concentration A being equal to what? Minus K dt. That's if we cross multiply here. We end up getting this. Now, upon having this, what we can do is just to integrate the left and the right. So integrate the left from A0 to AT. 1 over concentration A times D concentration A. Then you also integrate the right hand side from 0 to what? T of minus K dt. After that, if you integrate the left hand side, you end up having ln concentration A to the points of A0 to AT. And this is equal to minus KT to 0 and what? T. If you integrate the left hand side, you end up having ln concentration A T minus ln concentration A naught. And this will equal to minus KT. Because on this side, if you integrate, you only end up having a minus KT, because this 0 will neutralize the other one. So, if you make ln concentration A at a period of time t subject, you end up having ln concentration A after some time t being equal to ln concentration A at the initial point minus KT, and you have this. So this is called the integrated rate law for a first order. This is what you have for a first order. Then lastly, let's look at the second order. Remember, right is equal to what? Right expression. So this is for a second order. You can pause the video and try to attempt to do it on your own. So you have K concentration A squared being equal to negative change in concentration of A over change in time. This will be minus D concentration A over dt being equal to K concentration A squared. If we manipulate this point and do some cross multiplication, you get 1 over concentration A then you also have, so squared times D, if you manipulate concentration A being equal to K dt minus. So after that, you can just integrate this part. So if we do integrate, we end up having 1 over this, and we take the integral from A naught to AT. We do the same this side from 0 to t minus K dt. So if you take your integrals from the left and the right, you end up having minus 1 over the concentration of A to A naught to AT being equal to minus KT taken from 0 to what? T. Now this will give you minus 1 over concentration A at time t plus 1 over concentration A at the initial being equivalent to minus K at t. So 1 can just say times negative 1, and this will be 1 over concentration A at time t minus 1 over concentration A at the initial being equal to positive KT, making 1 over A at the period of time t subject. You have this being equal to 1 over that plus KT. So this is the integrated rate law for a second order reaction. Be mindful of this. So you need to know exactly how these things work. You need to know exactly the integrated rate law for the first order, 0 order, and as well as the second order. So in a nutshell, I could say for a 0 order, you have concentration A at time t being equal to concentration A at the initial minus kt. Then for the first order, you have in concentration A at time t being equal to ln concentration A at the initial minus kt. Then lastly, the second order, you end up having 1 over concentration A at time t being equal to 1 over concentration A at the initial plus k at t. Alright, so these are the integrated rate laws for the 0 order, first order, as well as what? Second order. Now, what you have to understand is this. Mostly, they don't really specify the order. So when they give you a question, sometimes they can give you the k value, which is the rate constant. And from the rate constant, you can deduce what order it is. Now, be mindful of this. For a 0 order, these are just pointers. For a 0 order, the units of k. Let's start with 0 order. So for 0 order, the k units are m to the 1 dot s to the minus 1. Then for the first order, the k units will be m to the 0 times s to the minus 1, or one will just write s to the minus 1. Then for a second order, the k units will be m to the minus 1 times s to the minus 1. Be mindful about this. Alright, thanks for watching. If you have questions, you can reach me on WhatsApp on the number attached to the screen there, on the number that I've put in my description. My name is Mr. Hussein Wasapi. Don't forget to like and subscribe. And remember to strategize before you become a statistic, and let's try and push for that A+.